All right, let's just dive right into this explainer. Today, we're unpacking something pretty mind-blowing, the invisible cosmic symphony. We are going to take a journey from the familiar light we see every single day all the way to the unfathomable waves we can't, and hopefully shift our entire understanding of reality along the way.
So, what if literally almost everything you know about the light you see, the colors you perceive, the whole world you live in, is just a tiny fraction of the actual truth? You know, coming into the 19th century, humanity was really just starting to figure out the basic laws of physics. We knew light existed, sure, and thanks to prisms, we knew it had colors. But science doesn't really mature until it has a system of measurement. If you can't measure it, you can't systematize it. So, 19th century scientists began asking, what else can we actually measure about light? We can measure its brightness, obviously. We can measure its color. But as they dug deeper, they discovered a paradox that completely broke the boundaries of traditional physics.
And this immediately brings us to a massive, head-scratching paradox: wave-particle duality. Basically, depending on exactly how you measure it, light can show up as a physical particle, which we call a photon, or as a continuous wave. It is doing both at the exact same time. And look, our brains fundamentally struggle to wrap around this truth. Back in the day, frustrated scientists even tried to mash the words together into a brand new term, wavel. Thankfully, that terrible word didn't stick, but the concept absolutely did. Light has a wavelength, and if you change that wavelength, the light actually changes color.
Which brings us right to our visual reality, and honestly, the ultimate mind-bending illusion, color. Okay, I want you to picture an apple. You look at it and you say, yep, that apple is red. That is how we experience the world, right? That's our everyday reality. But let's take a step back and look at what is actually physically happening when you stare at that fruit.
The reality of color completely shatters the illusion. That apple, it's only red because white light is hitting it, and white light contains the entire rainbow, Roy G. Biv, the whole shebang. So when that full spectrum of light smacks into the apple surface absorbs the orange, the yellow, the green, the blue, the indigo, and the violet. The only color it actively rejects, the only color it bounces back into your eyeballs, is red. So physically speaking, red is actually the only color the apple is not. It literally absorbed everything else.
I absolutely love this quote because it hits the nail on the head. Don't believe your eyes and don't believe your brain. Our language is totally trapped in our own limited framework. We say an object is a certain color, when in reality, that's literally the one color it rejected. White objects, on the other hand, they act like a perfect mirror, bouncing the entire spectrum right back at you. But if an object absorbs all the colors and bounces absolutely nothing back, we perceive that emptiness is black.
So let's switch gears a bit and see how this builds into the forces that actually create this light. Now, back in the day, early scientists looked at electricity and magnetism as completely 100% separate phenomena. You had electricity over here, the frontier science pioneered by guys like Ben Franklin, and then over there you had magnetism, this weird, mysterious force that totally obsessed a young Albert Einstein because it featured action at a distance. I mean, a magnet could move something without ever physically touching it. For the longest time, these were just two completely separate magical properties of nature.
But then, enter Michael Faraday in the mid-19th century. Now, Faraday wasn't a huge math guy. You won't find many complex equations in his writings, but he had this staggeringly deep intuitive feel for the physical world. He's actually credited with inventing the idea of a field. And he realized something absolutely crucial. If you take a wire and just pass it through a magnetic field, boom, an electric current suddenly pops up in the wire. He literally used a magnet to actually create electricity.
So, electricity and magnetism, not separate forces at all. If one can generate the other, and vice versa, they are just two sides of the same coin. They are the peanut butter cup of physics. You got magnetism in my electricity, you got electricity in my magnetism, two great tastes that go great together. Scientists literally just stapled the two prefixes together to give us electromagnetism. And here is the real kicker for us. It is electromagnetism that is responsible for creating light.
Now, knowing that light is an electromagnetic wave naturally opens up a massive question. If visible light is really just specific wavelengths that happen to tickle the receptors in our human retinas, what happens if you go past the visible colors? Like, what actually lies beyond the red edge of the rainbow? Well, that exact question was asked way back in the 18th century by William Herschel.
And guys, this right here is exactly how humanity stumbled upon the invisible universe. So Herschel had sunlight passing through a prism, spreading out a nice little rainbow spectrum on his table. He wanted to measure the temperatures of the different colors. So he puts thermometers in the red, the yellow, the blue. But crucially, and this is why he's a legend,
as any good scientist does, he placed a control thermometer off to the side, just outside the red light, in what looked like completely empty shadow. But when he actually checked the readings, no way. The thermometer that recorded the absolute highest temperature, it was the control thermometer.
In that exact moment, we realized our own eyes were completely failing us. Herschel published a paper and famously called it light unfit for vision. He had just discovered infrared, which literally just means below red. This was light that was undeniably real. It was emitting physical heat, but it was totally 100% invisible to human biology. And man, this kicked off a massive race. Because if there was invisible light hiding right next to red, what else was out there?
Well, over the next few centuries, we systematically started adding new, invisible windows to the electromagnetic spectrum. But to find them, we needed entirely new detectors. I mean, a thermometer works great for picking up infrared, but it's not going to do anything for a radio wave. Physicists soon started finding massive waves out there, some literally the size of a meter or even bigger. You know those old rabbit ear antennas on vintage TVs? Those actually worked because they were the exact physical length of the radio waves they were trying to grab right out of the thin air. And as we discovered shorter and shorter versions of those radio waves, we cleverly named them microwaves.
Now let's just pause for a second to appreciate some beautifully simple math. All of these waves, visible light, radio, microwaves, every single one of them travels at the exact same speed, the speed of light. Because of this, they have a perfect, elegant inverse relationship. If the wavelength shrinks, the frequency has to go up, perfectly balancing things out to maintain that universal speed limit. So imagine a wave rolling past you. If the physical wave gets shorter, more crests of that wave are going to hit you every single second. That is exactly what a higher frequency is.
And hey, speaking of microwaves, we stumbled onto a really fun accident with them in the 20th century. It turns out the water molecule absolutely loves absorbing microwaves. The story goes that a scientist was working with microwave beams in his lab, and after just standing near one for a bit, he reached into his pocket and realized his chocolate bar had completely melted. Now, he wasn't being cooked by radioactive fallout or anything. The microwaves were simply making the water molecules inside the food resonate and vibrate. That rapid vibration creates friction, and that friction is exactly what heats up your leftovers. Honestly, this entire spectrum is the bedrock of modern civilization. Going back to your microwave oven, it has a glass door, right? But there's a metal screen inside with tiny holes. Those holes are smaller than a microwave's wavelength, so they trap the light inside while letting you safely watch your food spin. Moving way past the visible light, we use ultraviolet to zap and sterilize medical tools. We use incredibly tiny X-rays to actually see the building blocks of matter. And we cap the whole thing off with the absolutely massive energy of gamma rays.
When you really stop and realize how vast that spectrum is, from massive radio waves rolling through the atmosphere to microscopic gamma rays, it becomes incredibly clear the visible light our eyes can actually process is just a tiny, tiny sliver. As the source material beautifully puts it, experiencing the universe using only our human eyes is like listening to Beethoven's Ninth Symphony, but it's being played on a one-octave toy piano. It's just ding, ding, ding. You are literally missing the entire orchestra.
But thankfully, modern astrophysics and technology give us the tools we need to finally hear the rest of that symphony. Sure, we are practically blind in our natural state, but through science, we have unlocked the entire electromagnetic spectrum. We are literally surrounded by a buzzing, vibrant, totally chaotic universe of invisible light every single second of the day. So I'll just leave you with this thought to chew on. If our eyes are really just a toy piano, how much more of the universe's invisible symphony is waiting out there for us to finally tune into? Keep questioning your reality, and thanks for hanging out with me on this explainer.